And so now what we're going to do is we're going to go on the back side of that page, which is the notes page. And on that notes page, what I will usually do in notes, like I do here, is they'll usually be guided notes where you just have to fill them in as I. Okay, so we are interpreting graphs today, relationships between linear and nonlinear. What does linear mean? What does linear mean? What word is in linear? Line. So it's referring to a line. So if something is linear, it's saying that it's a line. Okay, so we have linear functions and we have nonlinear functions that we're going to talk about today. So these are some linear functions. And so we want to interpret what this linear function is doing. So it is doing, as we go, if we start here at this point, it is going what direction? What's happening with it? Okay, good. And what would be a word that we could use if we were climbing up a hill? There, it is increasing or decreasing? Increasing. So it's increasing. And why do we say it's increasing at a steady rate? And so what about that shape tells us that it's a steady rate? That's right. It's not a curve. It's a line. So because it's a line, that means it's a steady rate. It's happening exactly the same speed as we go along there. So now it's moving, and if we start again at this point here, it's moving up or down? Up. As you go. So from the origin would be here, and that would be from left to right. Does that make sense? So then what's happening on this next line here? It's decreasing. And again, it's decreasing at a steady rate because? Why is it a steady rate? It's a straight line. That's right. And so we're moving in what direction? From the origin. The origin would be on the left. Moving down. So these shapes will be on a graph, and so that's why we're talking about them. We're going to be interpreting them according to what's on the axes of the graph. So you guys still looking at that? Move on to the next slide. Okay, so now we have some nonlinear functions. Nonlinear means not. And what's a math word we could use for that instead of straight? Not a line, that's right. So these are not lines. Does that make sense if this is not a line here? Okay, so we want to say what's happening there. We've got two different things happening. So if this is our time on this side and this is our distance, we have something that's happening from here to here and something that's happening from here to here. So both of them are increasing or decreasing? Increasing, but from here to here, it's increasing at what kind of a speed? Is it fast or is it slow? It's increasing fast. And the reason is that it's steep. So that's like a steep hill that's increasing fast. We're going at a short period of time, and it's going a long distance. Okay? So it's increasing fast. And then from here to here, what's it doing? It's still increasing, but increasing Is that fast or slow? So that distance is that time is the same amount of time from here to here. So it's going slow. So it's increasing fast, then increasing slow. And it's moving from the origin, it's moving up or down. Here's the origin on the left. That's moving up. Okay, so then on this one here, increasing or decreasing in this curve? So as we go from left to right, it's increasing. And then as it's increasing, what's the speed at which it's increasing? So this is flatter. So that would be, I couldn't hear what you said. It's slow. This one is slow because it's not going much distance here. It's going slowly. So it's increasing slow, and then from here to here we're going. So increasing slow. Then what is it? How is it increasing here? Fast, slow then fast. So see how that is steeper? So it's faster. Questions on that? Because I know that's kind of tricky there, increasing slow then fast. And it's going to come up a lot in this unit. So this unit is functions. I don't remember if I said that already. And then we're moving what direction? From this point, we are moving from the origin, we are moving up. Up as you go from left to right. I'm just leaving that off because when we say from the origin, that is assumed. But you can put that in there, it doesn't matter. And then what about this one? Increasing or decreasing? Decreasing now. So we're decreasing, we're going down. And then this part of the graph is increasing fast or slow? Fast, because it's steep, so it's quickly decreasing. So decreasing fast. Then this part of the graph is decreasing slow. And we're moving what direction? Down. And again, as you go from left to right, fill in the last two boxes on your own. I see some of you have already. So when we are decreasing on this one, it's decreasing again. And what are the speeds? This one is slow, then fast. Because we're going quickly down that hill, for example. And it's moving in what direction? Down. Okay, can I get somebody to pass out the worksheet? If you will. Friday, 6:30. Okay, so we'll talk about this for a bit. So this is from The Simpsons. Have they seen The Simpsons before? They've been around for a while. They're still around. Is there anybody who did not get a worksheet? Okay, so these are the characters, and they are watching the Itchy and Scratchy show. And so we've got a graph here. For example, this is Bart, and this axis is the amount of popcorn. Going up and down is the amount of popcorn, and then left to right is time. So we want to interpret what's happening there, and you're going to answer the questions that are on the back. So just pay attention real quick for this, and I'm not going to talk anymore for a while. Here, right here, how much popcorn is in the bowl at the beginning there? It's full. It's right up at the top. So we know that he starts out with a full bowl of popcorn. Does that make sense? Okay, go ahead and answer the questions on the back. I'm happy to help you if you have any questions on any of that. You can ask your group members. And eating, continues to eat, and then until it's gone.
Homer.
So it would be Bart.
Would it be Homer too?
So Homer doesn't actually finish it if you look at Homer's. His is at the very end. There's still some left in there. Does that make sense? It's flat, doesn't quite go down to the bottom of the amount of popcorn. And then who left the most in their bowl at the end? Lisa. So Lisa is up here. She's the only one that's up that high. So Lisa. And then whose bowl of popcorn got knocked over by the family's dog, Santa's little helper? So on this one, you could have interpreted either one of two, or either one of them is doing that. Let's say it's just one, and then we'll have another scenario for the other one. So which one might it be that the bowl was knocked over by the family dog? Marge. So let's say it was Marge. So when it's knocked over, all of the popcorn is out of the bowl. So if that's the case with hers, or here, then how might we explain that for Homer? Because those are the two scenarios that are the hardest to explain. There might be another explanation. Lisa, I liked your explanation. What did you say?
Homer just balanced his bowl.
That's right. In that commercial, or in that show, The Simpsons, He does that a lot. He'll take food and just pretty much inhale it. So you can say, yes, he just took it and inhaled it. So technically some time would be going by, but he's doing it so fast that it's not showing a curve. Okay, and then what's the difference between Homer and Marge's graphs? So there's a really big difference between them. What's different?
He refilled.
That's right. So he must have refilled his popcorn bowl at some point. Somehow taken some more popcorn, so it goes down and then up. Hers goes all in the direction of down or flat, whereas his goes back up.
There's other differences.
You're right. There's other differences as well. Then there's also on Homer's, we have, he's eating, I got to look back at the graph. He's eating at a consistent speed here. He refills it. And then what's happening here? So what kind of speeds does he eat at here? Fast and then slow. And then what about hers here? Slow then fast. So one is fast, slow, one is slow, fast. And then who started with the least popcorn in their bowl? Homer, that's right. This is farthest down on this side of the graph. So that would be Homer. And then what is happening in Lisa's graph in the beginning? What's this flat? What does that mean? She's not eating any popcorn. So what might be an explanation for why she wouldn't be eating any popcorn? We aren't asked to explain why, but what might be a reason why she might not be eating any? What's that? Yeah, sure. She's busy doing something else. So they're watching this Itchy and Scratchy show, so maybe she really likes it. So she's watching it and she's distracted. Or she couldn't not be hungry. And then Homer was when was Homer eating the fastest in his graph? When is he eating fastest? Is it this part of the graph from here to here or here to here? Or part of this in here? Part of that, so it would be from, let me make that in blue. So say from here to here would be when he's eating the fastest. Okay, and then because I want to give you the course syllabus, I'm going to stop here.